Hello guys, so today we are going to see how does increasing the nodes in a small network changes the load and CPU utilization. So for this, first we are going to consider a baseline scenario. In this scenario we have used a 3-com switch. This switch is a 3-com switch which has two superstack layers. The 1100 is a layer 1, which is a subnormal switching which is used for subnormal switching purpose, whereas the 3300 is a layer 2 switch which is used for switching and routing as well, whereas it has 52 auto sensing Ethernet ports, whereas 48 Ethernet ports and 3 giga Ethernet ports. So in total you can connect 100 nodes to this switch. The connections between the nodes and the switch and from switch to the server is made using the 10 base T link. It is a twisted pair Ethernet link which supports a speed of 10 Mbps. So now we are going to understand what is application definition and profile definition. So application definition defines the capabilities that a user has, whether you can use HTTP, whether you can use SMTP, FTP or other services, whereas profile definition defines the user and who is actually using it. So any request that is made to the node, that is made by the node to the server, is first monitored by the app and the profile config. If they check if it is allowed to a given user, if it is allowed, then the request is passed to the server. Now we are going to compare it with the heavy load scenario. What we are going to compare is our object statistics and global statistics, where object statistics are the statistics of the entire network. Global statistics are the statistics of entire network, whereas object statistics are the statistics of the nodes in the network. So now we are going to switch to the other scenario, which is heavy load scenario. In this scenario, as you can see, we have added another switch with 10 other nodes, and since we are using this router which is not configured, it acts as a switch and the load is passed through this switch to the node. So now we are going to check how does the performance vary. So first we are going to go to DES, choose individual statistics, you go to global statistics and you select the Ethernet and you select the delay statistics, since we need to see what kind of delay is generated. After this, now you will run this scenario for 10 hours to see how much does the load and utilization vary. It's running. So the results are now generated. So we will go to DES, we'll go to DES, we'll go to results, and we'll go to compare results, since we need to compare results of both the scenarios. Now we'll select the baseline scenario, we'll go to global statistics, Ethernet and delay. So now as you can see in this scenario, the blue one is the baseline scenario, whereas the red one is the heavy load scenario. So in the blue scenario, we can see there is a delay of 0.0004 seconds, and in the heavy load scenario, as the nodes have been increased, the delay increases to 0.0008 seconds. That is quite a great increase in the delay as well. Now we'll go to object statistics and check for the given node what is the statistics. So we go to Ethernet, we go to load per bits per second on top of this. Statistics, delay off. Okay. So now here, as you can see, the Ethernet load in the heavy scenario is approximately around 200 or approximately around 200 bits per second, whereas in the other scenario it is around 1000 bits per second. So since the nodes increase, as the nodes increase in this in the network, the load in bits per second approximately decreases. So the server since the load on the server increases, the performance decreases. So that is what this result is showing us. So that's it from my side. I hope you understood how increasing nodes um, changes the performance and the delay in the network. Thank you.